Hello everybody, I'm Sharanya. I work as a developer with ThoughtWorks. I'm here today to talk about feature toggles. It's actually a trend in software development, quite different from what we have heard about IoT and stuff. So it's hardcore software development now. So coming into feature toggles, it is a way of deploying latent code to production. So talking about latent code, right? Like what do we mean by latent or dormant code? Code that is not yet completely functional, in the sense it is under development, and it's not really production quality yet. So how do we manage different versions of code, right? So one version is production development complete and ready to be shipped to production. The other part, some of the other features are like still under development, and some of them are like ready for release, like development complete but testing ongoing and ready for release, etc. How do we typically manage these various versions of code, right? A very crude way is to have completely different code repositories. One repository which contains the production quality code, another repository in which we develop, etc. But that's like very old way. And some of the more frequently used ways is using version control systems, especially Git. We have branches like Git or Subversion. We have different branches. We have the development branch, we have the production branch, we have the release branch, etc. So that's there. But then I'm going to talk about a new trend, or like one that is like fast trending. It's about the feature toggles. So the difference between feature toggles and using a conventional version control system like Git is you can maintain both the development version and the production version on the same branch, like on the same trunk or master branch, right? So why would we want to do it? Why would we want to have both the dormant and deployable code together? We see some of the use cases, right? It just helps us to develop new features alongside release priority features, right? Like we don't have to stop development because of some changes or bug fixes on release priority features. It also helps us to ship everything in one shot and have the control at the runtime, right? Like you can control what the user sees once the code is deployed, and you can make separate controls there. So what do we gain out of this, right? It helps us to do something called canary releases. That is, we can turn on the features only for a certain set of users, right? If we have a new feature that is built in and it is available for production, and we're not sure like how it is going to perform and how users are going to receive it, we can turn on the feature only for a certain set of users, and they'll be able to see the new feature in place, while the others will not even realize that there is a change in the code that is deployed, would still function like normal for them. So giving different behavior for different sets of users is canary releasing, and this particular pattern will help us do that. And it also helps in A/B testing. It's also called as split testing, in which we have two different code flows, say two different payment methodologies or algorithms to suggest something to the user, and probably determine like which one will help the user buy more stuff on a say e-commerce website, right? Like what sort of suggestions should we give? Algorithms to suggest products to users, and based on the users, you could categorize the users and show different algorithm to each set of users, and design or like collect data as to who is buying more, and then decide as to which algorithm you could use, right? Like you could have two different code flows and show different sets of users these code flows and see who is like which one is best performing, and based on data you could take decisions on your workflow, right? Any questions? Am I in the hang, or like should I go deep?
One of the use cases like after deploying in production, turning out.
Yeah, sure. So definitely. So it's every time the case, right? When we deploy something to production and then we see an unforeseen thing coming up and like, oh shit, I had not tested this code flow, or probably I should like, somehow I should like stop this in production. How do we do that? We have feature toggles in hand, so we can like just have one flag which says like turn off this feature in production, and boom, that it's like as if you have not deployed, you don't have that code in production, right? So it will also help that. I'll cover that. So how do we really achieve this, right? So we have a toggle router, which is at the center. We have a toggle router, which will determine, which will make decision as to like what code flow I should show given when a user comes in. And we have multiple functionalities or multiple features which could like make decisions based on the toggle router, right? And how do we make decisions? There are multiple ways to make this decision. For example, you could make decision based on the incoming user. Like for example, that's what we saw in the A/B testing. Or you could make decision based on what the business wants. Say the business wants to turn off a feature, or because of some performance issues we want to turn off something. We could make decisions based on different aspects. We'll see as to what are the different categories we could make these toggles affect. So one important thing is we got to test with this config in effect, right? Like we could turn on a feature and we could also turn off a feature. So we need to test with both these on and off states before we deploy a code to production, just to be sure that our toggles are really working, right? Like when we switch off, we should be sure that in production it is still switched off. So it is actually work that we got to test with both these configs. So how do we make these toggles, right? Like what are the different ways that I can bring up toggles? So I could configure toggles to be environment specific, right? For example, a feature would be off in production, but it would be on in any other environment, say pre-prod or release or testing, right? So based on environment, I could make the toggle config differences. Or I could make runtime changes, like if I want to use an admin UI, I could use an admin UI to control whether the toggle is switched on or switched off. Or it could be more dynamic, like I could make decisions based on the incoming user. So if he is like a premium user, I could switch on some features. If he is not a premium user, I could like probably switch off a feature. So it's based on the incoming user. For that request, I could make decisions. So toggles in general could be categorized into two dimensions. One is based on the longevity, how long the toggle is going to live in our system, and another is going to be around the dynamic nature of the toggle. Like how am I going to determine which toggle is in action, right? Let's get into more details about these two dimensions. So these are the different sorts of toggles that are in place. For example, based on your need, we could choose one of these toggles. So the release toggles are more common and easy to relate to. That is toggles when we want to release a feature to production, right? So in development versus ready for production, right? So we can control those two using the release toggles. Details into these ops and experiment and permission toggles soon. So the release toggles are used to turn off partial or fully developed features in production. It is typically to help in the CD principle of separating feature releases from code deployment. Like what continuous delivery says is like you should deploy as often as possible, and you shouldn't be like hindering yourself by, okay, some feature is in development and hence I can't do the deployment this week and so on, right? So you can like just put the feature off and be ready to deploy. So you should also be like testing with the feature off state so that you are sure that this won't hinder with any of the ongoing features, right? So these release toggles are particularly static in nature, in the sense like even before the code is deployed, we make decision that this feature is going to be switched off, right? Static, like it is not going to change once we put it into production. We know before we push into production that this thing is just going to be off, right? So it's pretty much static. And if I want to change the toggle state, say I want to switch on something that is already off, I got to redeploy. Like I got to push a different version to production, then only I can make it on, right? So these are typically the nature of release toggles. So we could see that these release toggles are pretty much static, and they're also short-lived. Like for example, if a feature is like under development, and like say it takes only 2 months for a feature to get development complete, so these toggles will exist in the system only for about 2 months, right? So these are like very expected to be short-lived, pretty much static, and easy to test. Coming to the next category, it is about the ops toggles. So these toggles are, like as you mentioned, are typically used by system operators. They're used to turn on and off behavior in production. So this is just to quickly react to production issues. So it has to be dynamic. Like in production, we will not know whether the product. I mean, we can like turn on the feature and turn off the feature in production environment itself. So it is like very dynamic, short-lived or long-lived. For example, if something is not performing fine and we are going to fix it, right, we can like make the toggle short-lived. For example, we are developing a feature and we know that we're not very sure of the performance, but we want to give it a try. We can like quickly turn it off in production and then do the performance fix. And then once we are like very sure, we can remove the toggle. So that toggle could be short-lived. But when we compare to toggle, which could be long-lived, in the sense you could have areas in your application which are like typically not so critical, but nice to have stuff. But once you have an important product launch, you don't want your system to be bogged down by these not so critical features. So you could probably switch off those features only on certain critical times, like important product launch or something of that sort. So such toggles would be like long-lived categories depending on the need in hand, right? And ops toggles typically have to be reconfigured very quickly, because if you find something, you need to, in a snap, you need to switch it off. So we don't have the luxury of redeploying to change the toggle state. So it has to be very dynamic. So the next category of toggles is about the experiment toggles. So these are used typically to study user behavior, like when something is unknown, like which algorithm performs better, or the business finds it hard to choose between one choice and the other two contending choices. We'll probably use this toggle, like put both into development and put both into action, and have a specific set of users to go through flow A, and have a certain set of users go through flow B. And then based on the data we gather, like the performance, or the purchase turnout, or anything of that sort, we can make decisions. So this toggle will have a different logic for each of the users. So it has to be, the toggle will be decided based on the incoming request. So it is a dynamic toggle, and it just helps us to get data for decision making. So as we can see, these experiment toggles are like more dynamic in nature. So the last type of toggling that we would see is permissioning toggles. So these toggles are used for differentiating premium users from the system. Like for example, if you want to enable a certain set of features only for premium users, then we would use toggles again, and based on the incoming user request, we would identify what sort of user he is and enable or disable the feature. So, or it could also be used for alpha features, like testing some features only for some internal users, and then before we roll out to external users, we could test it. Since these are like typically catering to the user based category, so it has to be very dynamic again. So moving on to the different ways of implementing these toggles, right? So there are like various ways to get the toggles in place. For example, way is to have it hard coded and baked into the system. Like just have an if-else block somewhere in the code and determine what sort of toggle configuration to be chosen, and it's pretty much static. Whereas a more sophisticated or a better way is to parameterize the toggle configuration. So how do we parameterize it? Using things like command line arguments or environmental variables. We could like change the toggle state. So for example, when we have deployed a particular jar and when we want to start the service, we could like change the command line arguments, and then once restarting the service will give a different behavior. Parameterization is one option. A more better way, so command line, it's very difficult to maintain multiple toggles using the command line arguments, right? A better way would be to use the toggle file, which is a single file dedicated to have all the toggles in the system, which will maintain the toggle state. We got to redeploy when the toggle state changes. We need to somehow ship this file that contains the new toggle state to the server. So we got to redeploy to get the toggle state in place. More dynamic is to, instead of replacing the file with the database, so we could like have the toggle state captured in the database, and whenever we want to change the state in production dynamically, we could like go and switch values in the database. Evolve thing. And a more sophisticated thing is to use a distributed toggle configuration. We'll come to a use case of this. So it is like having some centralized server and multiple services could use this distributed toggle state. So multiple services in an ecosystem would read from a centralized system, centralized toggle server, which will give the same toggle state to the different services. So how is it going to be to work with toggles, right? Like from what you have heard so far, do you think it is like easy, or the way you've been doing it now is like better and more maintainable, right?
The point is, because the CSS or case, in our case, we manage too many versions on a single. The time it will be 50 to 60 versions. That's on the server. But going with toggle, is it going to add weight to the production code? Because already you are having too many logics built into the code. Toggle to the code. Again,
Yeah. Yeah.
It has to pass through the case.
Yes.
I understand it is going to solve some critical issues after it goes for production. But again, looking at, initially, immediately when I saw the topic, I got excited. But again, when the type of toggle and maybe, then my mind started to asking so many questions. Whether it is going to be impact performance of the application, it is going to burden the hardware, and lot many things.
Yeah, you're right. With toggles, there comes some complexity. It is not easy. It is like additional logic, right? Apart from business logic, you have also this toggle logic to maintain. Like, how do I ensure that this user is going to go through code A as per my needs, and the other user is going through code flow B as per my needs, right? So, and that also increases the testing complexity, right? I need to verify like the conditions are satisfied. So the trick lies in the way we implement the toggles, right? So if we keep all related toggles and their decision making at one place, testing would become easy and the implementation would be like less hassle free. But if we start sprinkling if else code all over the place, right? Like once the logic changes, or even the toggle scope could change. For example, like determining the purchase flow might be just based on the user, but then it could change based on some other parameter too. So the toggle scope also would change. So having the checks in multiple places should be like, it should be the minimal check possible, and the decision making should be contained in one place. So that way your testing and would be like contained. It is definitely one additional complexity, but it can be kept in check. Right?
So anyway, you're running like the 60 plus versions, right, for each customer. So if you consolidate into like one version, source code, which probably you can run one instance to handle all those customers, and you don't have to run those instances for those servers for each customer, right? Yes, there is a overhead in the code for this the CPU or even the very minimal. There's overhead in the processing time. But you don't have to run a server or service even if a customer is using it or not. Practical use case example is, we are working on the customer for last year where they had actually like 20 different versions, 200 different customers. We got versions and implemented not exactly toggles, but it's like multi-tenancy, right? Or these are like extended forms of toggles. So where you don't have to run different toggles, one instance and all customer. And in fact, you will end up saving hardware related to that. Yeah, one another challenge is the giving up the unused express toggles, because like those versions that is already running in the production, we don't change it so easily. Right?
Yeah.
The express toggles we keep on and it's not getting feasible.
One prudent way of managing toggles is by limiting the number of toggles, right? So number of active toggles and of course cleaning up the expired toggles. Otherwise it will be like the toggle scope, too many things coming into, and overlapping toggles are a nightmare to manage. Unless it is like a real necessity, we got to clean it up. So it's additional complexity, so we can get rid of the complexity as and when it is needed by cleaning up the toggles, and also by having a judicious expectation on the number of toggles, right? We can't have like 100 different toggles in the system. It is wise to have like 10 or 15 toggles. I mean to say the business toggles, right? For example, if we have different code flows for the same thing, it is somewhat meaningful to have like 5 different code flows than 100 different code flows for the same algorithm, right? So though it is a feature, like we need to like have some limitations on it. Another thing that we have to watch out for is building a rule engine, right? The toggle scope and the toggle decision should be kept as simple as possible. For example, like should I send email, right? Should be just a true or false thing, or easily determined logic, right? But if we couple a lot of things, then it becomes like from when on should I send email and stuff like that. So different toggling decisions will be based on different, like one would be based on a date, another would be based on some other thing like presence or absence of API or something like that, or like presence or absence of some data or something like that. If we keep toggles more complex, like rather than simple Boolean values, we would end up building a rule engine rather than a feature toggle system, right? And containing all of that in one system and testing it would become a problem. So keep your toggle router or toggle decision maker as simple as possible. The thing is, as I said, decouple the decision points from the decision logic. So the logic could be kept, the decision making logic could be kept in one place, like one file, and you could like instantiate that class and make if-else checks in multiple places. So that way, in order to check the logic, you can always come back to that one class, make changes, and make sure that all their use cases would be like if-else is enabled or not enabled. That would be the checks in multiple places in your code base. But what is the condition to determine whether something is enabled or disabled is in like one place. Moving on. So we know that toggles bring some additional complexity and some ways to check it. But how do we enable ourselves to help manage toggles? One important thing to note is to put all toggles in one place, say in one file, or choose one mechanism. Like if you're going with the DB based, go with the DB based for like all the 10 or 15 toggles that you have. Some in files and some in DB, etc., would make it difficult to determine the toggle state. For example, in a pre-production environment, what sort of toggles are active and what sort of toggles are disabled should be like viewable by viewing one file or like selecting from one table, etc. So that way we could like keep things in check. Is to prudently avoid overlapping toggles. Like for example, making two toggle decisions come hand in hand, and like then we'll have like instead of handling just on and off state, we will have get into four states like on and off, this one on and off, etc. So instead of getting into those permutations and combinations, we try to like limit the scope and separate them. We got to test with both the toggle on and off, and also have our automated tests with both these states. Like if your automated test is designed to, generally it is designed to test with the code flow on. Now when we introduce the toggle, write a test which will like make the toggle state off and still get the system in a saner way. So one other difference that we could see is where we typically place these toggles, right? So of the different categories that we saw, some of them, or like most of them, were like user based. So these toggles would be typically in your edge or entry point of your system, like where you like meet the user for the first time. From the HTTP header or from the cookie, you can make the decision. So it is your toggles would be at the entry point. We come to some of the release toggles, right? Like some of the algorithm switchers, etc. They need to be inside the code where we decide like which code flow to be used, right? So different types of toggles need to be placed differently, either at the entry point or sometimes deep inside the code. But it is better to make the decision as early as possible. As soon as we like receive a request, as early as possible, we need to make the toggle decision. So that will help keep the complexity in check. There are some ready-made tools available for some of the most common platforms that will help us with feature toggling out of the box. So we have used the toggles for Java. It will help us make the toggle decision based on the HTTP header using it. So there are tools available for this. Coming to my project experience, how we have like gone into this. So we started off with the file-based approach, a very static approach, like a file holding some of the toggle states. But then we soon realized that being very static and having a code deployment every time to change the toggle state is like not enough, and we want it to be somewhat dynamic. So DB based. And we also did the mistake of running into some more sophisticated controls. Like we didn't have just Boolean values. We had like dates in one place to make the toggle decision, and we had in other place. So it really became complex when we wanted to generalize it across the services. So I had worked in a microservices architecture. So typically the same toggle, like a new feature that is being developed, it cuts across multiple services or code bases. So when I have to make the toggle decision in one place based on a very particular date, and then the other place might be unaware of that date. So it becomes very tedious to reuse and create across services. So we had to like drill back to be more simple toggle. Then as we evolved, like from one services, we had to extend the feature toggling to multiple services. So we had distributed key store rather than just DB based. So we actually used Redis for this purpose. So this is like a centralized Redis server, which stores the toggle states. It is dedicated for and all the services would establish connection to that and read the toggle state from that. So given any environment, all the services will have a particular feature A turned on, and all of them will be like tested with that configuration in effect. And when we have to like turn it off, we go to the Redis server, turn it off, and we know that everybody will be like will have that feature turned off. So that way we could like ensure that all the services in the ecosystem would follow a common toggling state. Some of the tenets that helped us in this development is we made sure that once we got into this trend of feature toggling, we made sure that every new cross-cutting feature is so we can't have the thing like some feature would not begin with toggles. Like any feature that we start development, we need to put toggles in place that will help us deploy the code and get rid of development time hindering any sort of deployment. So every new feature was toggle enabled. Now, another important thing is we need to ensure the data consistency between the two toggle states. For example, when I have a toggle turned on, right, and the data gets into a particular state, and when I have the toggle turned off, or the code should be able to work with the existing data, right? So the data consistency should be maintained across the two states of toggle. These are some of the things that helped us manage feature toggles in both development and production. So I missed the thank you slide. I'm done. Any thoughts?
Say we have an API and you want to get something that you want to profit, probably what you do is you go back and you see that API, can you make this more compatible than you say so to see the toggle in place, you may probably have a different API in place. Something like that, or we man the existing API. And when we turn on the rock or when we remove, like moving forward, like say the old something, you would probably get rid of your old code and everything, but you still have to be if we have to say like we better when new API. By then somebody else could have used the old API for some other purpose.
Yeah.
So then that's a problem. Right? Yeah. We have to use the API for this. So nobody has even paid attention to even consider whether that can be achieved with single obvious slight confidence.
Okay. Yeah. Generally, with the API, right, there is compatibility coming into place. As you said, there are already users using the existing API. So it is I mean, depending on what the use case is, we could achieve it with feature toggles, but I think the API contract needs to remain the same. If it is complete change in contract, then introducing a new API and slowly deprecating the old one is the way to go. Something deep under the infrastructure, like for example, the contract remains the same, but then your way of implementation changes, then feature toggles would be definitely helpful.
What do you think about versioning? Versioning, let us say, first version I have done with 1.0, and I have got changed the contracts have got changed. And why not we use 1.1? That would be different contracts.
Yes.
So that, yeah.
So versioning is one with
feature toggles. The versioning itself will solve this problem.
Yes.
I was going to say exactly that. So what you're describing is a versioning, API versioning, not exactly feature toggling. So what you and different of current form. So whether you have the old feature or new feature, you still want to support the consumers of both the API, right? So from what you said. So you have to still maintain the old version of the API, even if you move on to the new implementation step code, like within the application.
Yeah, like when you say API, it's not only a lot call the necessary. It's not, I mean, when you see an API, we easily whether it can access the old consumers and API consumers, other callers, wherever like other places. So as to appropriate this thing. So that we do not go and write a whole new API from getting companies.
So
another thing is that the data consistency. When we have a migration of old data to new data, what we consider was instead of getting a drawing built on top of it, because we have to maintain this data consistency. That's going to be more complicated compared to having a downtime and
okay, so the data consistency is typically when between two toggle states, right? Like when you are in production and you are like you don't have a situation but to turn off a feature, then your system should still be able to work with the system would have been on for some time with the feature being turned on. So that would have left the system in a particular state. So when you switch it off, the system should be able to continue from it dynamically, because we are not talking about redeployment or restarting of services at that point, right? So it's actually a trick, and only by testing you could like ensure whether it is possible, and you never know what sort of data inconsistencies could actually appear at that point. So testing really helps. Cool. Any more questions? Yeah.
Logging is classic case where we have been doing such kind of things before, and it's not exactly a problem, but where we are logging before we are code is actually just based on the configuration. So not exactly feature everything, it's a correlation. And the logging framework, we have approached and
okay.
we don't have this configuration just based on the versioning, this turn on and off. Code would still be there.
Okay, so you mean the log levels, right? Like info or debug or error, and only on certain cases these logs appear. Yes. Yes. It's a way of relating to which code flow would be chosen, or when something would become active. Yes. Yeah, it's basically an implementation detail of the logger framework. They could use toggles in. Sorry, can you say that again?
Let us say you are having rules
Rule engine, yes.
That is
So rule engine is for somewhat a more complicated flow. So if you look at something like a release toggle, right? When something is under development and it is likely to go into production a few months later, but I got to release today, then I can like turn it off. But a rule engine is like too sophisticated for that purpose. But so there is only a slight mark between that. It depends on your use case. If your toggling decision is like too complex, probably a rule engine, and you have multiple such toggling decisions, probably a rule engine is the solution. But if you have like simple toggles that has to be like on and off, performance fixes, etc., then this comes in really handy, and it is like easy, not as complex. Cool. Thank you for your patience.